I think it's best to answer them right then when we're right on the topic. At least that's just my opinion.
Okay. Well, let's try that.
Okay.
Okay. I guess I can introduce Randy. I heard his presentation at a Native Plant Society of, trying to think of where it was, South, sort of Central Texas Society, and I was impressed with what he had to say and how little of that I actually knew. So I thought he would be a good speaker for ACC, since we have a lot of gardeners and a lot of people that deal with the soil. Randy comes with a extensive background in, I guess, he's graduated from Texas A&M with a degree in wildlife and fisheries science. And then he has his own business that works with native plants. So, and worked for the Dallas Zoo. It's the first time I think I met you when you were doing some work with the prairie group in around New York Avenue, Blackland Prairie.
Yes.
You gave us a lot of interesting tips on how to manage that park. So he comes with an extensive wealth of information for us, and I'm very pleased we got him here. And take it away, Randy.
Well, y'all, it's an honor to be asked to speak. I really appreciate y'all letting me do this and offering up the platform. You know, I'm an organic horticulturist. I propagate native plants. I do consulting, but I learned as an organic horticulturist early on that, you know, if you're a gardener, everything we see above ground, if it wasn't for soil biology, it wouldn't be there, and nor would we, obviously, because plants are the foundation for just about everything. But we'll get into that in a minute too. But so soil biology, the hidden world beneath our feet. And y'all, this picture, I actually took this out of a compost pile. And one thing you're starting to see right here is it's not soil structure, because this is compost, it's organic matter, but this is structure. And soil structure development mimics this exactly. The white stuff you see here this is fungal hyphae. Fungi grow, the hyphae is a Greek word for foot. It's just basically this long thread-like filament. And they break down organic matter using organic acids. So everywhere that fungus touches, it's secreting a little acid that will start breaking down the organic matter. But look what it's doing too. It's also acting like threads. It's knitting these different pieces of matrix together. So look at all the different sized things there that are knitted together. That now has structure. And so soil biology does that with our soil as well. Very important that we have that. That's why we don't really want to till. So now this just kind of, I have a plot at the Lake Highlands Community Garden. I'm on the board of directors there, and this was at our compost pile. And somebody thrown away some kind of squash, and, you know, from the decay comes, you know, new life. And this little excerpt down here is just a poem from Alexander Pope. All forms that perish, other forms supply. By turns we catch the vital breath and die. So when stuff dies and breaks down, it feeds other things. So that's again integral to the organic horticulture and organic, being organic horticulture. So this is integral for us. Y'all don't really try to look at this and try to memorize it. I just want to introduce the complexity of this, and I want to introduce a term, a phrase, trophic level. This is called the soil food web. And over at the far left-hand margin of this diagram, you'll see you got plants, shoots, and roots. Y'all, the sun's up there, and this plant, what they're showing us here is photosynthesis. And through photosynthesis, the plants will create food for soil biology. It's called root exudates, but they produce proteins and starches and carbohydrates for the sole purpose of feeding soil biology. They want to attract soil biology to their root zone and have them eat and actually poop there, because soil biology poop is plant food in the organic natural world. So, but the first trophic level, look, it says photosynthesizers, and those are plants. And they're feeding soil biology. So trophic levels are what that defines is a food level. When something eats something, if a hawk eats a rabbit, that's a trophic level. If something came along and ate the hawk, that would be a second trophic level. The more trophic levels you have in a system, the more that indicates it's a good indices of complexity and sophistication. So the more trophic levels you have, the healthier the system as well. So look right here, before we even get above ground in a healthy food web, we have 4 trophic levels. The first one is the photosynthesizers. You see organic matter there, waste residue and metabolites from plants, animals and microbes, bacteria and protozoans eat that. That's the first trophic level. Second trophic level, you can see nematodes, fungi, bacteria. Third, protozoans, because the protozoans are eating the bacteria. So you can see what we're talking about here. There's a lot of stuff going on. So what I just want to illustrate with this is how complex it is. There's a lot of moving parts in a healthy system. So if you've been using chemicals on your lawn, weed and feed fertilizers, things like that, you have compromised this, and you need to get this back. So what we're going to discuss in this presentation are basically the 3 major roles of soil biology. There's a lot, they do a lot. Most we don't even know, understand, but for our purposes of going outside and looking at our garden and going, wow, this is what I understand. The 3 things we're going to talk about are nutrient cycling, soil structure development and maintenance, and disease and pathogen suppression. So I can tell you, when I was director of horticulture at Texas Discovery Gardens and the zoo, in our beds, once we put native plants in and we did the mulching and prepped them first with some compost, we didn't fertilize the lawn. We didn't fertilize the beds. Vegetables are different because they're heavy feeders and they're annuals. They grow quickly and they do their thing fast. So you've got to add a little bit for them. But disease and pathogen suppression, I never had to do anything for pest control ever, even in my greenhouses, because I had this dynamic work in native plants and I was organic. That is key. So you get a lot of bang for your buck when you do this. Nutrient cycling, let's talk about this. What is it? Number one, I picked this picture on purpose because it's a tropical rainforest, and the first thing people think of when you say that term is lush, green, lots of plants, and that's true. But the soil there is very infertile because of all the rain. A lot of the important minerals and nutrients get leached out through the soil system or get basically washed away. So if you didn't have, like when a leaf falls off a tree and hits the ground in a tropical rainforest, it gets eaten up and converted and recycled like overnight. It happens fast. So it's that dynamic that allows it to be so lush and have all these plants. So if it wasn't for that, no tropical rainforest. So it's extremely important stuff. It's the conversion of organic matter in a form, from a form that plants cannot use or other animals can't use, into forms they can use. Immobilization and mineralization. Here's what that is simplified. And I'll use us as an example. If you sit down and eat a hamburger and it gets in your tummy, it's immobilized. It can't go anywhere else. So you've eaten it and you've ingested it, you've immobilized it. The mineralization part is the poop. When you get rid of what your body doesn't use at all, because if it did, we wouldn't have a need for a restroom. So when you go in there and you sit down and poop, now I'm not trying to be crude or funny, but that's the nicest way to say that word I know of. That's called mineralization, because basically that is changed from the hamburger, which you can throw a hamburger out in the yard and you're not feeding your plants. But if you go poop in your yard, you've mineralized that hamburger and turned it into a form that plants can actually use. And then specialized cycling, specialized nutrient cycling. We're going to talk about nitrification, nitrogen fixation, and sulfur oxidation. And y'all, I go through these quick and make it pretty simple. Specialized cycling, this is a bacterial monopoly. Only specialized bacteria do this. So if you use a lot of chemicals on your lawn and you don't have any bacteria, here's what you miss out on. Nitrification, that's the conversion of ammonium nitrate into bacteria, from ammonium, the conversion of ammonium to nitrates in bacterial dominant soils. So in bacterial dominant soils, there's these nitrifying bacteria that they ingest ammonium, and one specialized set converts it to a nitrite. And then this other one comes along and eats their poop and converts that to a nitrate. And that's a stable form. And that's the form of nitrate that I talked about earlier that your vegetable garden wants. So you need bacterial dominant compost if you're a vegetable gardener, and that's what you use it on. And for your lawn, grasses like that too. But my point here is not for you to memorize all this, but just know that bacteria do that, nothing else. Specialized bacteria. Nitrogen fixation. Specialized bacteria fix atmospheric nitrogen. Our atmosphere we're breathing is like 76% nitrogen, but it's not available to us. But these bacteria can fix it by attaching a hydrogen atom to it, basically. And they live on the roots of legume plants. That's why you can build your soil with green crops like vetch or peas or beans, and you till those in and put them in early spring and till them in, and they will have taken free nitrogen from the atmosphere, and when it breaks down, it's now in your soil and available to your plants. Specialized bacteria, sulfur oxidation. Sulfur compounds in our soil are not in a form that are available for plants to uptake. They have to be changed into sulfates. Specialized bacteria make that conversion. So right here, 3 very important processes that bacteria are responsible for, and only they can do it. And if you don't have these 3 things right here, sulfur oxidation, that almost all green plants require these sulfates. So right there, you've wiped out almost all terrestrial ecosystems if you don't have that. So point, not trying to turn you a soil biologist and have you memorize and understand all this to a deep, just know that that stuff is there, it exists, and one of the goals of this talk is to tell you how not to compromise your soil biology. These are the little things when the bacteria start colonizing, these are plant roots. The dirt's been washed away off of. This is a legume, like a bean or a pea. And when the bacteria they basically burrow into the roots and they form a gall. And then this gall is what they live in. And so there's air underneath the ground in these microscopic pores. We'll get to that in a second too. And that's where they get their atmospheric nitrogen. They live in there. When the plant dies, these guys die, and then they're mineralized, and that nitrogen released back into the system. So nature's pretty cool. Y'all, that's nutrient cycling in a nutshell. And you can see how important, bacteria are for that. So let's talk about soil structure, development, and maintenance, and what soil biology, what role they play in that. What you're looking at here is basically some structured soil that has a root going through it. And what I want you to notice here is look at all the white spaces between the soil. Most of the time we think about dirt, we think about it being solid beneath our feet. Well, it's not, it's very porous. Different soils, different soil types have different soil porosity. But you can enhance this no matter what. And so Phil was talking about the bare spots in the yard, and I'm talking about, you need to get more water down in there. Well, you need soil structure to do it, because y'all, here's something I want you to pay attention to here. Water does not move down through a soil profile by gravity. It does it largely by capillary action. Now, don't get me wrong, if you've got a gopher-sized hole, water's running down that hole by gravity. But when it gets down there where there's no big giant holes, have you ever seen the little glass pipette that's stuck in the glass of water, and that water level rises higher than the level in the glass? That dynamic that causes that is capillary action. That little curve on the side of that's called the meniscus. That's the water trying to climb up the side of that glass. Same dynamic happens in the soil. When those pore spaces get really small, it will actually pull that water down through the soil profile by capillary action. But you have to have soil structure to do that. And so when the outside of an earthworm is slimy. When it moves through the soil profile and it's leaving that slime layer behind, that slime actually binds up soil particles together. That's one way soil structure gets there. When the bacteria secretes their enzymes to break down organic matter, those enzymes are wet, it's a liquid. Those things start binding soil particles. When they poop, that starts binding things. So all this soil organism activity, all the stuff they do, creates goos and slimes, and these things start knitting these particles together. And then remember that fungal hyphae? That's like thread-like stuff running through the soil that actually bonds it together. So all these different actions are working to create this. And when they do, they create these soil pores. And that pore space is where areas that's very important for plant roots. So basically I just described this is just showing you what I just described, but soil structure also creates a home for soil biology. The bacteria are tiny. The next biggest thing basically is a protozoa, and protozoa hunt down and eat bacteria. Well, bacteria don't like to be eaten. They want a hiding spot, so they need a tiny little crevice to get in, littler than a protozoa. Then other things eat protozoans. They want to hide too, so they create a home for soil biology. Now, here's another thing I want you to concentrate on too. Soil structure creates an increase in soil cation exchange capacity. CEC for short. Do y'all remember in school, if you have magnets, there's two ends, there's polar ends, negative and positive. If you put the two negative ends together, they repel each other. If you put a negative and positive end together, they attract each other, and it makes a bond, a real strong bond. Our soil, organic matter, and soil particles, especially clay, are negatively charged. Cations are ions of things like iron and potassium and ammonium, that first form of nitrogen. They're positively charged. So they'll actually make chemical bonds like a negative and positive charge. Soil particles and organic matter is negatively charged. Cations are positively charged. They actually bond together. So if you've got a lot of surface area, a lot of soil structure, that's just more surface area for these cations to bond to. So your capacity for those cations is increased by soil structure. Very important, because you want those elements. Those are good for plants. Plants need those things. Those will not be washed away in a rain because they are chemically bonded. They're bonded to the soil particles. Anions, however, are not. They are negatively charged. They will not bind with soil particles like that. And if they go into solution like nitrogen or chlorine or things like that, chloride, excuse me, they can get washed away. But if you have that soil structure, remember, that tiny pore space that will hold that stuff in place, they will stay in the root zone. So look how important soil structure is. So well aggregated soil particles, good soil structure, here it increases soil porosity. That's those air spaces. Our biology that's important to us is aerobic. They want air, so that's good for them. They can have more of those if you have a lot of air. It's an increase in capillary potential. That's what we talk about for retaining and moving water down. You want the water to stay in your soil and not running off into the street. And rototilling, I call it a rototiller, I call it the soil biology Cuisinart. It destroys soil structure and negatively impacts soil biology. One earthworm cut into 10 pieces does not make 10 earthworms. It makes one dead earthworm. That tiller will till up your earthworms.
Can I say something?
Randy,
Yes,
can I ask a question?
yes.
Randy, I wanted to make an observation because after many years of composting and adding compost to my garden, my soil particles are, crumbly instead of powdery. And I think that's what you're referring to, right? The particles are like crumbs.
Yes, ma'am. That's what you're doing. You've done that. That's right. They've started building that soil structure. Now, let me ask you: when you change out like from your spring to your fall plants, do you shovel that soil and work it, or are you a no-till, or do you just drill a hole and put your seeds in there?
No, I don't till.
You don't break it up at all.
Yes, just the space for a seed or for a plant. Of course, you got to make a hole, but just minimum.
Y'all, and this is important. I want to stay on this just for a second. So let's say are you a wintertime and fall gardener as well?
All the time.
Yeah.
Good. Well, good. Okay, so like when you're
so much
transitioning,
vegetables as native plants as the native plants.
well, and this goes for native plants too, but what I'm talking about is when you're with your vegetables, when people are transitioning from their cool season to their warm season stuff, let's say, we go from like right now, let's say we're coming out of wintertime, we're going into spring and our lettuce is bolting and our cool season stuff is about to go to flower. A lot of people will pull those things, and I've got this thing on the screen. I'm relating this talk to what these roots you're looking at. They'll pull the lettuce out and they'll do that. Don't do that.
Do that.
Here's why. The soil biology exists primarily in what we call the rhizosphere. It's the surface of the root to about 1/10 of an inch out. It's not very big space. So if you're trying to get rid of those plants and you pull them out by the root, look at all the soil biology that you just removed from your garden. Now, you say, well, I can't, number one, let me just back up and say one thing. That wintertime stuff, when it bolts and flowers, that's always the first pollen and nectar that's available to insects. And you'll see beneficial insects like crazy around those little tiny flowers, especially parsley and dill and fennel. They love those umbelliform flowers. But so if you pull this out of the ground, you have pulled out all the soil biology there. Now, another thing too, what you want to do is cut it off below the crown. Like here's the surface of your soil. Here's a plant growing out of it. If you take a shovel or a trowel, and I'm going to pull my hand out here because now I got it. Pretend it's still there though. So the plant's still there. If you come in here with your shovel, I'm gonna get this. It's hard to do this. You come in here at an angle and you cut down through the soil like that below the crown. That plant will not come back, but you will leave this underground. Now, what will happen is that plant will be dead, and when the soil biology consumes these roots, they'll move. And let's say you've planted that was lettuce, and now you've got your peppers and your tomatoes in there. You plant them right beside this, and they will migrate from this root system right over to the root system of the plant you just put in there. And this shadow of all these roots will be left somewhat in that soil. And what is that? Those are little passageways for air and water and soil, and little critters will go through there. They become superhighways for soil biology. So when you pull weeds, you're not pulling them. You're going to cut them off below the crown and just leave that root system in place. That's a good question.
That's what
Very good question.
Great.
So y'all, here's I was digging in the ground in the prairie, and this is a piece of black clay right out of the prairie, but look at all the structure. You can see there's holes there where worms, something's going through there. And right here, well, you can't see, but if that round hole can y'all see the round hole right in the middle of the screen? That looks like a black hole, round hole, the roundest hole right in the middle of the screen. Can y'all see that?
Yep.
In the clod. Look at about the 5 o'clock position, about 1 inch away from that hole. You see those little pellet looking things? They kind of look different. Looks like a little oval, oblong looking thing. Well, those are earthworm castings that have been left in that ground at about the 5 o'clock position from that black hole. Well, I'll show you a better picture here in a minute. That's on my soil knife. There's just another big hole. But look, you can see, look, there's a lot of different size crumbs in there. And see how they're all stuck together? All this gums and slimes off the soil biology made that structure. That's real good structure right there for clay soil. There's your Cuisinart. So y'all, let's talk about, and I'll get to some of that other stuff back again here in a second. Well, let's talk about disease and pathogen suppression. On your screen right now, what you see, that's a nematode. These are microscopic worms, and there's a bunch of different kinds. They do a bunch of different things. But what it's ensnared in is a fungi. That's a fungus, and that's a predatory fungus, and it is eating that nematode. It's going to dissolve it with some acids. So, and some of these nematodes, you'll see right here, there's a deal called root knot nematodes in a minute. And tomatoes can get them. They burrow into the roots of the plant, and they eat the roots, and in response, that root puts out a scar tissue that makes the root almost impossible for it to transport nutrients and water and stuff. They're real bad. So these guys are some of the things. Now, sometimes they may eat a good nematode, but they're indiscriminate. But just know that you don't have to buy a lot of stuff back. You don't buy ladybugs. Nematodes are one thing that you can buy that can be effective, and I'll show you some pictures of that in a minute. But if you're an organic gardener, you don't have to buy a lot of extra supplements, especially if you make compost. If you do that, you pretty much don't have to do anything. Y'all, and if you make compost tea with your compost, you should, because you can use it as a foliar spray. This is black spot on a rose bush. If you're spraying your leaves down with compost tea, that biology will actually colonize the surface of the leaf And if that fungal spore lands on the leaf, a lot of times you'll have good stuff that'll eat that spore, and you won't have this fungus on your roses. The white stuff you see here, this is mycorrhizal fungi. Any kind of fungus that's a mycorrhizal fungi, what they do is they attach to the roots of plants, and they go out there, and phosphorus is a big one that they go out from the soil and they bring it back to plants. And from the plants, what they get is carbohydrates from the plant's photosynthesis, a symbiotic relationship. Almost all plants on earth have some mycorrhizal association. Although we have killed a lot of the fungus in our soils using weed and feed fertilizers or high nitrogen fertilizers, salt-based fertilizers over the years. So y'all, want y'all to think about something too. I hate to have to use the example, but when you see it, like on the news, when a tornado's gone through somewhere and knocked over a big old tree and pushed the tree over, the root systems of trees extend way beyond the drip line. I see some of these trees are like, they got a 50-foot wide canopy, and when that tree's pushed over, look at the base of that tree. Those roots extend out from the base of that tree about 2 feet. What has caused those roots to pull back that far? It's over fertilizing the lawn. It's that salt in there kills all this biology. And I mean, so that's why them big trees fall over. Big trees don't just fall over like that. That's one reason why. So here's one of the missing links right here, mycorrhizal fungi. So I want to talk a little bit about the individual components that make up soil biology, the players. What are they? We talked about bacteria and protozoans and fungi here a little bit, talked about a nematode, but let's talk about them and what they do. Bacteria, they're the most numerous and most diverse of all the soil biology types. We've talked about the 3 basic soil processes that they monopolize: nitrification, nitrogen fixation, and sulfur oxidation. So we've gone through those in detail. So there's bacteria here. Here is a specialized bacteria called actinomycetes. Y'all, that little green thing's a bacteria. Look at it. That's it. It has no arms, has no legs, has no thread-like filament. That's it. Wherever it's touching, you can see where it's touching that yellow stuff, it's secreting an enzyme. And that enzyme is now going to break down that organic matter, which is probably what that is, and then it's going to absorb it back through its membrane. That's how it works, which you can see. Here's another kind of this brown stuff. This is another kind of bacteria, specialized. It's the second most numerous soil organism, actinomycetes, and it's specialized bacteria because it acts like a fungus. Look at it. It's a thread-like structure. It's the brown thing in this picture. It can grow. It's growing a hyphae-like filament, so it has more surface area. It can break down more stuff. And it's good at decomposing brown materials. Look. Fungi and bacteria can both break down either green juicy leaves or hard bark, brown dry bark. They can both break them down. But because of what those 2 different things are composed of, one's better than the other. The hard brown stuff is composed of carbon chains, and carbon chains are very strong bonds. It's hard to break those down. Enzymes are not very good at breaking apart carbon chains, but acids are. So fungi decompose things by using acids, organic acids. So that's why they're better and more efficient at breaking down brown material, but they can also break down green stuff. Bacteria use enzymes. Enzymes are better at breaking down soft, green, sugary stuff, better at decomposing those things. They're not as efficient at breaking apart carbon chains, although they can do it. Here is one bacteria that is very good at breaking apart carbon chains. They're very common in manures. And here's another thing too. When you dig into dirt or into compost and you get that beautiful earthy smell, this is the organism responsible for that. So if you've got that smell, you know you've got this in your compost or in your soil. And it's an indication of good soil organism diversity. Y'all, I collect seeds to grow my plants with. I just throw this in there. This is persimmon seeds. I needed some. There's a process called scarification where there's a thick seed coat on seeds. And then when they pass through a gut of an animal, the acids in the gut break down that seed coat and allow water to come into the seed, which is the beginning of germination. So if you're out collecting seeds, don't ever turn your hand away from manure, because it's already passed through the gut of an animal and these seeds are ready to be sown. And y'all, this is the kind of thing that makes me different from most presenters. Most guys ain't going to tell you to grab up a bunch of manure just because there's a bunch of seeds in there. But I'm telling you, it's a good thing to do. It's efficient. It's nature's way. I'll tell you how to make it work. It ain't always the most pleasant thing, but let's talk about fungi for a second. The #1 decomposer of organic matter on Earth. I've heard it said that if there were no fungi, in less than 2 weeks, the whole surface of the Earth, the terrestrial surface, would be covered in about 2 feet of leaves and organic matter. That's how fast this stuff breaks things down. Nitrogen released by fungal decomposition is in the form of ammonium, the first form. These things can consume both living and dead matter. You saw the picture of the one eating the living worm. And then let's talk mycorrhizal fungi, how important those are. You want to study that, that's a whole nother subject. I've got a 300-page book on that subject alone, and I've only gotten in about the first 10 pages, and that was 10 years ago. Pretty complex. So look, if you put mulch on your beds or on your garden, when you first put it down, it's all loose and everything, sometimes you'll notice that it forms a crust. Has y'all ever seen your mulch form a crust? What's doing it is the fungus. The fungal hyphae is doing that. You need to break that apart because it impedes water. It kind of water, sheds water like a duck's back almost. You need to break that up. If you do it though, wear a mask, because when you break it up, you're liberating a bunch of fungal spores. It's not good to breathe that stuff. But look how it's knitted all these particles together, and it's breaking them down. Leaf litter, y'all, leaf litter is it's called leaf mold, actually. This is really good for vegetable gardens, really good. Here's mycorrhizal fungi. 90% of all plants form some kind of, association. Fungi receive carbohydrates from the host plants through carbohydrates and root exudates. And they supply phosphorus and a lot of other things to the plants. But y'all, all the white stuff you see this is fungi. And what it does is basically expands the root system of a plant exponentially. What we think now is the biggest single organism on Earth is about a 200-acre patch of mycorrhizal fungi somewhere in the Pacific Northwest. They've done DNA testing so far over 200 acres, and it's coming back to the same DNA. And that's one solid mat, 200-acre mat of mycorrhizal fungi underground. And you can imagine it is making connections with every plant that's growing on that 200 acres. Not every plant is now connected. They're all sharing stuff, sharing information, sharing nutrients, talking to each other. When one's under stress, listen to this. And these aren't even the same species. When one plant's under stress, it can talk to another plant via roots and say, I got this problem. Can you spare some sugar, basically, or whatever? It sends it over. Now that is co-op. I mean, they're competing with each other above ground for stuff, but not really. If you look in a forest, canopies don't really mesh that much. That's in a healthy system. That is real cooperation. That's a real beautiful thing, and that's evolution to get to that. Now let's talk about protozoa. It's real important. Primary, flagellate, ciliates, and amoeba. Y'all, here's the thing. We want to keep our nutrients in our soil. We don't want to have to buy fertilizer as organic horticulturists. We want recycling to do this for us. Nitrogen is very important. Amino acids are composed of nitrogen. Those form proteins. You got to have all these building blocks. So look at this. Protozoa. All protozoa primarily consume bacteria. One protozoa can consume up to 10,000 bacteria in a day. Now, let me talk about bioaccumulation real fast. If every one of y'all I'm looking at eat a hamburger, and I come along and eat all of y'all, I don't get just y'all, but I get y'all in the hamburger y'all ate too. So look at here. One protozoa eats 10,000 bacteria a day. What happens if a nematode eats 100 protozoans a day? It doesn't just get the 100 protozoa, it also gets 100 times 10,000 bacteria. It's getting a lot of stuff. That's a lot of bioaccumulation. So as much as 80% of the nitrogen needed by plants comes from waste produced by protozoa, which are eating bacteria and fungi. So protozoa, if we didn't have them, we'd lose 80% of the nitrogen that's available to plants in a natural system. That's a lot, 80%. So protozoa are extremely important. What do they eat mostly? Bacteria. Bacteria are extremely important. No bacteria, no protozoa, owning up the chain. Look at all these different trophic levels. I'm watching the clock. I show we got about 20 till 8. Here's some examples of some protozoa. Nematodes. Let's talk about these microscopic worms. Most are beneficial. They break down organic matter. They prey on bacteria and other soil organisms, so they have a lot of bioaccumulation. You can use them as biological control agent if you get grubs typically in your soil. Read this little blurb at the bottom. Nematodes as organisms, they don't require a lot of nitrogen. So when they eat stuff that has a lot of nitrogen in it, they mineralize a lot of nitrogen. In other words, they don't use it, so they poop it out. Nematodes are very effective mineralizers of nitrogen, as they use less nitrogen than protozoans. So more nitrogen is excreted as waste by nematodes than protozoa. So I didn't really throw that protozoa part in there, but when protozoas eat bacteria, they metabolize, they need it for metabolization purposes, a lot of nitrogen. So when protozoans poop, they don't poop out a lot of nitrogen because they've used it all. Nematodes are different. They don't need to use a lot of nitrogen for their metabolism, so they poop a lot of it out. So it's extremely important to have nematodes. So all of it's important, but they're just another reinforcing more evidence of how important these guys are, how important all of them are, and they will only exist in healthy soil that you are responsible for. And the easiest thing to do is just don't use chemicals. Here's a grub. Look at all the little spaghetti looking stuff in there. Those are nematodes. They have eaten this grub alive. Yes, this does work. One of the few things. Root knot nematodes. Healthy roots on the right, on the left. Root knot nematodes have started eating these roots, and look at the callus tissue that's been formed. They will not transport nutrients and minerals and water. That is a very inefficient root at this point. Crop rotation, especially tomatoes. Don't plant them in the same spot every year. Thank George Washington Carver for that bit of information. Here's an electron microscope of a nematode eating another nematode. So some of them are predatory. Got him folded up in his mouth. Arthropods, primarily mites, springtails, ants, and termites. What do those guys do? Y'all, if I tell you to eat an elephant, it's going to be too big. You can't run up there and with your mouth take a bite out of an elephant, and they're just too big. But if I chop the elephant up into 1 million pieces, now not just me, but maybe 10,000 people can get their mouth around an elephant because we've chopped it up into small pieces. We've increased the surface area. It's estimated that 30% of the organic matter shredded by soil organisms is done by springtails and mites. Very important initial decomposers. Initial decomposers. They break this stuff down into fine particles so that a small bacteria, protozoa, or fungi can wrap their mouth around it. So if you throw a big old chunk of wood, a log that's big enough to throw on a fire out there in the woods, it sits out there for a long time before it decomposes. If you take that same log and run it through a chipper and then spread it out on the forest floor, it might decompose in 3 months. If you take that same log though and turn it into sawdust and spread it out there, it goes away in a month. Simply because you've increased the surface area, more of this stuff can get a hold of it, it breaks down faster. These guys shred stuff. They break big stuff down into little stuff. They increase surface area. They are great initial decomposers. This is me. I was in Colorado. This is 6 foot of snow beneath me. And I started looking around, and what's on my fingertips, I saw this black stuff. I was like, what is that? Covering the snow surface. And I noticed they were moving. So I put my hand in there, and they got up on me. And here's a close-up shot with my macro lens. These are springtails. That little thing down here at the bottom, they will jump. They can jump with those. I found out what they're doing. These guys come up in the wintertime, they come up to the surface, and they find their mates and they're breeding, and they go back after the males, you know, mate with the female goes back down through the snow, lays her eggs in the soil, and that's how. But that's what they were doing in the middle of winter. But that's a springtail. Earthworms, y'all, getting to the end of this now. Earthworms.
Excuse me, Randy.
Yes, ma'am.
We have a question.
Yes.
The slide of your healthy and sick root masses.
Yes.
Can you go back to that real quick?
Right there. Yes, ma'am.
Now, what exactly is the left and right? What is
Okay,
that?
the right, it's the same. This is the roots of a tomato plant, which are susceptible to root knot nematodes. The roots on the right are a healthy root system. Look at them, nice and straight, nice and slender, tapered. They're white, they're beautiful. That just looks like we see, like most of our roots look like. Same species on the left. And the reason that little worm's called a root knot nematode, K-N-O-T, is look how knotty those roots are now. So what's happened is, let's take the roots on the right now. Those little microscopic worms have burrowed into those roots. And in response to that, these roots form basically scar tissue, and it grows around calluses around where that thing is eating. And that will not transport. That is like a clogged up drain, basically, because it swells. Like, see that's swelling basically, and it swells around those capillary tissues in that root. It squeezes them. So you squeeze a water hose, you're not going to get water through it. So that's what that basically does right there. And if you've grown tomatoes in the same spot for a couple of years, you should pull up one of your plants by the roots just to look to see if you've got this. And if you do, a good way to do that is just, because most plants aren't susceptible to this. And I'll tell you one thing to do: a companion plant alongside your tomatoes are marigolds. Marigolds secrete a substance through their roots that repels root knot nematodes. So if you companion plant, you'll have less of these issues as well. And y'all, the organic approach is an integral approach. It's a multifaceted approach. There's no one single thing. It's a cure-all. Nature doesn't do that. Nature offers things in packages of high diversity, typically. And so, like I said, you don't have to know one thing remember anything about this topic after we get through, other than there's soil biology out there. No matter what you've been doing to your soil in the past, if you just stop doing it, it will recover. You can help it recover fast by using compost. That's inoculating your soil with the biology. So compost teas are even better at that, because you can have more of the organisms in a smaller amount, and liquid's easy to disperse. So this topic excites me too. I don't know if you can tell that, but it's very interesting. Like I'm saying, it's a game changer, because actually your work is less. I mean, I love gardening, I love plants, but my idea of fun is putting the right plant in the right place and then leaving it alone forever. I never want to touch it or jack with it or have to do anything to it. That is not smart. I want to work with nature and not against her. She's way smarter than I ever will be. So let's talk about earth, and I welcome any question. Y'all just come on with them if you got them. Earthworms. An acre of healthy garden soils contains, I can't see those numbers, 2 to something million earthworms, 2 to 3 million earthworms. They can deposit 10 to something, 10 to how many?
10 to 1, or 10, yeah, 10 to 1.
10 to 15 million
Yeah,
tons of
okay,
Thank you. 10 to 15 million tons of castings per acre annually. Million tons of castings. What is an earthworm casting? Well, when an earthworm, what do? How do they eat? They just eat the soil. Their mouth open, they're tumbling right through the soil, eating dirt. Well, what are they getting in that soil? We've already talked about bioaccumulation. What are they getting? They're the biggest thing there. So when they're eating soil, they're eating the nematodes, they're eating the protozoa, They're eating the bacteria. They're eating all those separately, and they're also eating all the ones that have bioaccumulated. They're eating all the protozoa that ate all the bacteria. They're eating everything. Their role includes shredding organic matter. Earthworms come up to the soil surface and pull leaves and organic matter down, and they consume it. So they move stuff down into the soil for us. You don't have to till stuff into your soil if you've got earthworms. They transport organic matter and soil biology through the soil profile. They do immobilizing and mineralizing. Vermicastings. Y'all know what earthworm castings look like? Y'all seen this stuff on the surface of the soil after a rain? Typically, you'll see these little piles. Y'all think about this. Earthworm poop. And this is talking about soil that has passed through the gut of an earthworm versus soil, the same soil right beside the soil that the earthworm passed through and ate, the same exact soil that it did not pass through the earthworm's gut. Here's the difference in them. In the earthworm poop, it contains 50% more organic matter than the surrounding soil. And look at these numbers down here. It contains as much as 7 times more phosphates than the surrounding soil that has not passed through the earthworm's gut, 10 times the potassium, 5 times the nitrogen, 3 times the magnesium, and on and on and on with every nutrient that's in the soil available because of bioaccumulation. So if you go out there and collect these castings, and it doesn't take many, look how powerful they are, look how concentrated they are, and you make your compost tea with those, you've got the super elixir right there. Just add that to your potting soil, add that to your potted plants, add that to anything you can get your hands on. And I want to talk about one thing real quick, because we talked about it earlier about the earthworms that you might use for breaking down kitchen scraps. Some nurseries will carry earthworm castings. I've been in that business. Those castings are different than what I call wild castings. And here's how they're different. They're still good, but they're not a patch to their daddy, and here's why not. The bioaccumulation. So when you take your potato peelings and your onions and your whatever, and you throw them in that bin with your earthworms, your compost earthworms, they're eating that stuff, and they're pooping it out. So you couldn't feed your plants the onions or the potato peelings or none of that, but you put them in there, and they pooped them out. But there's no bioaccumulation. All you're getting is the poop, the residue from there's a little bit of bacteria. Don't get bacteria covers everything, but not like we're talking about in the soil. So you're getting the waste that's broken down from the potato peelings or whatever. Think about the difference of the wild castings. It's the bioaccumulation that's making the difference. They're just not the same. When that earthworm is eaten, it's not getting the organic matter. It's not getting the bacteria. It's not getting the protozoans. It's not getting the nematodes. So it's a night and day difference. And let me tell you something else too. Those earthworm castings you buy at the store, they are expensive, extremely expensive. So you can get it free. And I tell people to use this stuff. Go get it. City parks are a great place to collect this, because typically cities don't have enough money to put chemicals on their parks. So that soil is usually pretty good. And let me tell you something else too. If you see earthworm castings, no country boy is going to go to the dinner table unless there's food there. You're not going to see earthworm castings on the top of the ground unless there's soil biology down there, because that earthworm wouldn't be there eating through that dirt if there wasn't soil biology there. All of us have done, if you've gardened for a long time, you've dug in soil where there's no earthworms. They're not there because there's no soil biology there, or not enough to support them. Is one of the main reasons, not the only reason. But if you're somewhere, what I'm getting to is if you're somewhere and you see a lot of earthworm castings, probably organic, simply because if it wasn't, they're using a lot of chemicals. The soil biology, the food to feed the earthworm wouldn't be there. And what you'd see in that case would be one mound of earthworm castings here, and then 100 yards later, another one. But what I'm seeing at city parks around here is it looks like a minefield of earthworm castings. It's a very rich environment. So there's a lot of good, healthy earthworms there. That's probably organic. Y'all, here's a up close of earthworm castings that have been rained on. Look at that big blob in the middle. You can see the little tiny pieces of organic matter. It looks like little pieces of mulch. Well, that's little because the earthworm casting's tiny, but look how they've shredded that and broken that down. That's what we're talking about. Now that's even shredded. So now bacteria, they can really get after that. So all this process, and look how these earthworm castings are sticking together. What's holding them together? Well, it's sticky when it's coming out of that poop and all that slime and stuff. So it's already got soil aggregation and soil structure just in the earthworm poop alone. And it will add that dynamic to the surrounding soil. So and here's this is what they look like. Look how even they are. They look like little pellets. And you can see there's some little quartz you can see stuck in there. I can see little pieces of organic matter sticking out of the sides and various pieces of that. So look, very, very rich, very good stuff to make compost tea with. Real quick, I should talk about that. The easiest way to do that, if you've never done it before, 5-gallon bucket, use rainwater. Takes about a cup of castings. Get you some molasses. Carol, you talked about that at the first. It's got to be unsulfured. What do we make some of our antibiotics with? Sulfur compounds. It must be unsulfured molasses. You want to feed the biology, you're going to breed it. Put your castings right in the bucket, throw them right in the water. You need an aquarium air stone. Oh, like kids, if you had an aquarium, you had a tube that went in the aquarium, you had an air stone. The more air, the better. Throw it in there, throw all this stuff together, turn the air stone on. How much food to that 5 gallons and that 1 cup of castings? About a 1/4 cup of molasses. Throw it in there. And y'all, I have done this for this company I did. I worked for them. We made compost tea. I have brewed this stuff for all different kinds. And let me just tell you, between 36 and 48 hours, just stop right there. If you go longer and you get more of the biology in there, you're going to need more air and more food. It becomes a lot more complicated. I'm telling you, for a 5-gallon brew, 36 hours, if you stopped at 36 hours, you would have a nice, healthy compost tea. 36 to 48 hours is plenty. It's actually foolproof at in that little time parameter. That stuff, direct drench in the soil. Again, sprayed on the surface of your leaves. Use it daily. You could drink the stuff. You can't burn your plants with it. Impossible. It's just the best stuff. And let me tell you why you make compost tea. In compost, if I take a cup of compost, physical compost, let's say there's 1 billion organisms in there. If I want to take that 1 billion organisms and grow it into 50 billion using physical stuff, I've got to throw this in there in another big compost pile, and it takes a long time to break it down. It takes them a long time to breed. But if I take that still handful of stuff, I throw it in a bucket of water and give it some air and food, they're like rabbits. I can turn that 1 billion organisms into 10 billion in 36 to 48 hours. And that number's just relative. But you're just increasing those numbers. And the more numbers you can throw out there into your system, the more organic matter they can break down, the more nutrients they can liberate for your plants. You just gotta, look, if I got one mouth, if you gave me 20 mouths on my head and then stuck me down in a hog trough, I could eat 10 pounds of food in 5 seconds. You just got more stuff in the system. That's why you use compost tea. And again, for the foliar application, you can do so much, like especially if you're a rosarian, you get sick of black spot, do some foliar spray with some high quality compost tea and just watch that little problem. Powdery mildew, compost tea, foliar applications. Compost, you want to do some composting, that's at the Lake Hines Community Garden. I don't know why, those actual bags they biodegradable. See that thermometer in there? If you're going to make compost, you've got to have a thermometer. If your compost thermometer isn't shaded like this one, that gray area that's a nice deal. But look at 160. Actually, between 150 and 160, your pile's going to get hot. The heat comes from the bacteria, their metabolism. You know, if you're sitting down, everybody's sitting down right now, you're a certain temperature. If I made you get up and run 10 times around your house, you'd be hotter than you are now. That's all that is. That's just metabolism. Bacteria makes a compost pile hot. Well, about between 150 and 160, we're going to volatilize carbon. It's going to go into the air. We're going to volatilize. We don't want that. That's one of the things we want to hang on to. So when your pile gets too hot, how do you cool it? You cool it by introducing air. Now I don't use the barrels. I've done it all. A pile on the ground doesn't cost anything, and it's the fastest, best method. I understand people are limited with space, but go spend $300 to $600 for that barrel. You have to turn every. You can't add anything to it. You got to. It's just a big old pile. Here's what you do: you don't turn the pile, and when you turn it, you don't turn it in on itself. You just turn it to another spot. Before you do it, this is cooling your pile. Before you do it, the outside of your pile is naturally going to be a little bit drier. The soil biology wants a moist environment. So, and I'm not telling you to saturate your pile. You never do that. Before you turn your pile to cool it, water the outside down, because what you're going to do is you're going to take that outside stuff, because it's on the outside, and you're going to turn that. You're going to now start a new pile. So you're going to start with your shovel, your fork. That's what I'm doing. I'm forking my stuff. You fork it over here, and you're going to move it over here. If you just turned it like that without adding a little bit of water, you'd now have this core of dry stuff, and it's hard to get moisture down into that. So now if you water it a little bit before you turn it, as you start breaking into that pile, you're going to find as you get in there, that pile is moist, and you won't have to. But that introducing air is how you cool that pile. And it will also start that cycle over again. You have different layers, different species of bacteria that they start out. Cryptophilic, they like it cold temperatures. Mesophilic, they like it middle temperatures, 100 to 120. Then you get your thermophilics, they like it. So, and the environment changes every time. As this temperature increases and it gets too hot for the cryptophils, the mesophils are loving it, the cryptophils are moving toward the outside of the pile. They move away from that heat. Each one of those different kinds of bacteria has a different role in breaking this stuff down. So you want to have this gradient, this increase in this temperature going up, because you're watching the species composition change of your bacteria. That's what you're doing. You want that. You want that diversity. But again, then there's bacteria that live above the 160-degree range. But again, at that point, we're going to lose our carbon, and we don't want that. So that's why we turn it back in on itself. And when you turn it, that's starting the second run, and that's when you can start making your pile fungally or bacterially dominant at that point. But you always let it run first on the 1-to-3 ratio to start out with. That gives you the nice diversity. You can use that composting just generally. But and you can do that again, go back with the 1-to-3 to add, because you got to have your pile's going to shrink down. That's another reason. It's a good reason now to tell you why you got to have a certain size pile if you're going to do this, because you have to have it big enough to maintain its thermal mass. Because when they create that heat, it's creating the environment they like. They like that, they can get in there and do their work, right? But if your pile's too small, the heat will just dissipate, and they'll never be able to establish themselves because it's just too radical of a temperature swing. But if you've got a big old giant pile, and I'll tell you how big my piles that I learned how to do this were about 6 to 8 feet wide at the base, and I built them up in a pyramid shape till they were about 5 or 6 feet tall. Had all my materials ready to go before I started that pile, and in about 12 to 16-inch layers as I built it up, I would give it a little sprinkling, not saturating it, but moistening it down. By the time I got through, in about 3 days, man, the heat was on, and I mean, it was really starting to work good. And but you got to have a big pile, because it's got to be big enough that it can maintain that thermal quality. So I hope that makes sense. Because y'all, I've spent some time on compost, because compost, it is the game changer. Once you learn how to make it, it's got so many applications, and it's all nature uses. I didn't get that comment.
Yeah.
Can we ask a question there?
Oh, absolutely, yes.
Okay. Randy, my question was, what do you think of cold composting?
Well, I don't know what that is.
Okay. That's cute.
Well,
Well, that's where you pile everything there and you let it sit until it decomposes.
well, you know what I would call that? I would call that natural composting, because when you
Okay.
build a compost pile, what you're trying to do is you're just trying to accelerate the process.
Right.
What you
Okay.
just described is the natural process.
Natural. Oh, so I've been calling it the wrong name.
It will work. No, it will work. That's the way nature does it. Although nature typically spreads her stuff around, she doesn't bring it to the same spot and, you know what, and create a dump site basically. Because if you bring it to the same spot every day, that isn't really mimicking nature, but it will still work. It will still work. And so that's just it's a good, I've never heard it referred to as that. But so again, when you bring the browns and greens together and you make that big pile, you do that. Why do we do that? Because usually we have a yard full of waste and we don't want to bag it up and throw it away. So we have a lot of it, right? So you make a big pile.
Right.
And it's a way to break it. We don't want the pile there forever, and we want to be able to use the stuff, so it accelerates the decomposition process and makes it, you can use it in 4 to 6 weeks. You can have a usable product, and that's pretty fast to, you know, and that's what we're supposed to do. Is recycle that stuff, not send it to the landfill. So
Exactly.
so y'all, it all begins with the soil for us. Dirt is inert, but soil is alive. Everything above the ground is dependent on soil organisms that we rarely encounter or even think about. But be kind to your soil, and you'll be richly rewarded. So go organic, use compost and compost teas. I say the stuff with the most diversity. What I mean by that is, in your compost pile, have a lot of diverse elements, as much as you can. Let's say all you got, well, all I have in my yard is, you know, I got my lawn and I got a bunch of live oaks. Well, guess what? There's going to be a lot of people this time of year that you're going to see on their curb. They have a bunch of bagged up leaves. Now, if you're pretty sure that they don't use chemicals, let those bags sit out there till right before the day that the people come. Because when you get that bag to your house, what's happened is the moisture in there and the heat that's built up in there has already started breaking that stuff down. And when you break that bag open, you're already halfway there. That is some of the best stuff to start your compost pile with that you'll ever find, is somebody that's already bagged their leaves up and they've been on the sidewalk for 2 or 3 days. That's primo stuff. And so, like I said, if you only got live oak and St. Augustine to offer up, then, and you need something else, you know your neighbor has a maple tree or they got a cottonwood or whatever, go get some of that stuff. That all, because let me tell you, here's how I describe that. Who on here is going to argue that broccoli isn't good for you? You can't get everything you need from broccoli. If you want the diverse soil organisms, you got to have diversity in food sources, because some stuff don't like stuff and some stuff won't even break some stuff down. So mulch can do it, but don't overdo the mulch. Most people I see overusing it's too thick. All you're trying to do is cover up bare soil. When you have thick plants, go out in the woods sometime. You never see mulch the way we see it. Those are wood chips. You see leaves and stuff. So if you get enough plants growing, like in your beds and your perennials, the leaves they drop is enough mulch. Just don't clean your beds out. There's the rule there. And y'all use native plants. This isn't some xenophobic thing I'm talking about here. This is because our native pollinators co-evolve with our native plants. And I'm going to tell you right now, y'all probably don't know what the genus of a native plant called astragalus is. It's a prairie plant. I was doing a prairie rescue this spring, excuse me. They're fixing to build some warehouses out here. And I was collecting astragalus. And at my foot, I watched a native bee go into that flower. And it was about half the size of a European honeybee. And the first thought that came to my head was, the European honeybee cannot pollinate astragalus. So for our native ecosystems, that is a native plant, native pollinator relationship that maintains that. And the same thing in China, Japan, India, North America, South America, Mexico. No matter where you go, where you live, everybody should be planting their own native plants to support their own native pollinators, because that is the foundation of their ecosystem. So there you go. So y'all, here's the deal. I put that up there, not for my business, but I do grow native plants from seed. My genetics are local. That's what makes me different. I grow them organically. But here's some of the stuff, some of the services I offer. But another thing too, the main thing I want you to get is my email address and my phone number. If you have any questions about this and you want to follow up, feel free to let me have it. And any questions right now, I'll accept too.
Randy, this is Phil. I do have a question about the tilling. And so right now I have a little it's a little garden tiller where you just do it with your hand and you twist it. So should
Right.
I not use that anymore?
Well, you know, like I said, if you're scratching in the first top 2 or 3 inches,
Yeah.
y'all think about this. In nature, there's a lot of things that interact with the top 2 or 3 inches. Squirrels digging, lots of stuff digging around, armadillos. There's a lot of stuff there. And the soil biology has actually co-evolved with that. That biology that lives in that layer is used to being turned upside down and jumbled all over the place. It's when you start getting deeper, I say below about 2 inches, especially 3, that's when you start getting the stuff. There's very few things that dig down that far. I mean, I'm not talking about feral hogs, but
Yeah.
if something's burrowing down, they go through that layer. But if something's looking for an acorn or it's just foraging around, what it's looking for is in the top, the grubs, roots. They're looking at the top 2 or 3 inches of soil. So you can disturb that and you're okay. But it's that big one that I showed you that, the tines that are 6, 8 inches, that's what you don't want.
Right. Okay.
It's a good question though.
Yeah. Thank you. Thank you so
You're welcome.
much.
Y'all, another thing too, let me tell you something too. When those rototillers, when that tine comes around, and they've done studies on this, when that tine hits the ground, it sends a shock wave through that soil, and it starts soil compaction about 12 inches below where that tine is hitting. So if your tine is digging down and you're going down at 6, 8 inches, and you're down, and that tine is now, and it's making that circle, and it's hitting the bottom of that deal at 6 to 8 inches. Well, 12 inches below that, you're getting compaction. And when that compaction starts there, then it starts building its way up. And so you're not just compacting the soil up here at the top, you're compacting it real deep. And why that's terrible is, and like where we live now, y'all, this all used to be prairie for the most part. If you want to restore your land, that's why you get prairie grasses, because prairie grasses send roots. They can crack through heavy clay soil, they can tough soil, they can penetrate that, and they have fibrous root systems, and they go deep. And water will migrate, they will follow those roots down. So, and they can go through that kind of compaction. But so that's how you can correct that kind of problem, though, with native grasses. But boy, that regular rototiller that I just described, that's something that you just don't ever want to use.
Yeah. I think I usually, because I'm not that strong, but when I've been using it, it's probably maybe an inch. I maybe go down an inch, maybe an inch and a half. I don't go, yeah.
Yeah, but you know what? Think about it. With the tiller I just described, the one that had that long, heavy tine that made that L shape.
Yeah.
No matter how shallow you till with that, because when that flat thing comes around and it hits the ground, 12 inches below whatever level you're tilling with that kind of rototiller, with that kind of tine, that tine that hits like that, you're getting that compaction. The one that I thought I heard you describe it looks more like the old timey edger I used as a kid that had that little star looking thing. That thing just kind of grabs stuff and just kind of shreds it. It's not that L-shaped tine that's coming around and hitting that soil like that. Does that y'all recognize the difference in the tool I'm talking about? Let me do something real quick. It's this paddle shape.
Up there, it just passed.
You see that?
Oh,
look at that
yeah.
wheel.
Oh, no.
When that paddle shape comes around, that thing is turning fast. When that thing comes around and it slaps the ground, that sends a shock wave down through and it compacts that soil. The other thing I'm talking about just looks like a star. It looks like this, and all it does is it's got these sharp points. It's not called a garden weasel. I think y'all have seen those commercials. The
Mhm.
tine is not bent like that. And all it basically does is it just kind of, it's like ratting. Like when women used to rat their hair, you're just kind of ratting the soil like that. Women used to rat their hair. That I can tell how old I time you am. Remember they used to,
Yeah.
then the Aquanet came out.
Yep.
Oh,
Okay, well, anyway. Anyhow,
oh, that was
so
good.
that's why that kind of tiller right there is bad.
Yeah,
Bad,
now,
bad.
yeah. When my tiller, what I'm saying, I'm the tiller. I'm just moving the handle. It's maybe about, I don't know, 3 feet long, and it's got a little handle, and you just twist back and forth and back and forth. And by the time it's a really good calorie deal, because I'm telling you what, I get myself worn out with that thing. But it's very small. It's nothing mechanical like, the one that you've got on the screen right
Oh,
now.
I think I know what you're talking about. Yes, I know exactly what you're talking about. That's the thing. You kid and you twist it like this.
Yeah, you just twist it back and
Yes.
forth. You just like,
And
yeah,
at the bottom, it's just got this cloth thing that just does this. Oh, see,
Yeah.
that's basically you're just mimicking a squirrel. You should call that the squirrelerator or something, because that's really what that thing is. But yeah,
I
that's
mean-
like a little claw. That's fine. That's not even gasoline powered.
Yeah, exactly. It's
That's you
human
powered. Yes, ma'am. So I recommend and let me tell you something. Those kind of tools, go to state sales and find those, because it's better quality steel.
Yeah.
And you know what? You can leave your shovels out in the front of your house on the sidewalk. Nobody steals shovels because nobody wants to use them.
Yeah.
They're
Yeah.
lazy. A thief is never going to steal a shovel. That's a good rule of thumb.
Yeah.
Your hand tools are safe. They ain't going to do it. It requires effort. Although, let me tell y'all something. I got to tell y'all this real quick. I'm getting home the other day, and I live in kind of a mixed race neighborhood, and I saw this young black kid kind of hemming and hawing around on the sidewalk, and it's not the best not the best neighborhood in the world that I grew up in, but and I wouldn't care who it was. If it was a young person, I'd be looking at him, and he had a leaf rake in his hand, which was unusual, backpack on, and I was watching him. He was walking halfway up to the door of these houses and turning around and kind of shaking his head like this and talking to himself, and I watched him do that 3 or 4 times, and he passed my house. I stand in the front yard. I guess he looked at me and said, "Oh, I won't go up to that guy." But anyway, first thing I noticed was his pants were pulled up all the way, and this is a young black kid. I said, "Well, hey, what are you doing with that rake?" He said, "Well, I'm trying to make some money." And I said, number one, I was like, about 15 years old, and he got over to me and said, "A young kid trying to make money with manual labor? When the heck is that ever?" Last time I ever saw that, I was a kid doing it. But anyway, so I said, "Well, what are you were trying to say?" "Well, I told my mom I wanted something." She said, "Well, son, if you want something, you got to get there and earn your money to buy it." And I'm like, there's still parents out there. Dang, that's great. So anyway, I paid him a little money to rake some leaves up off the sidewalk, actually into my yard, which he was like, "You don't want me to rake them up?" I'm like, "No, I actually want them in my yard." So, but y'all, when you want to give up, and I thought I'd give up on the youth, thinking the youth today they're lazy, they ain't no count. But here was a young man who had taken up a piece of mechanical tool that required physical labor, and he was going to, I said, "Well, son, why don't you go up to the door all the way? I've been watching you." And he goes, "Well, I don't know what to say." I said, "Well, just walk up there and tell him, I'm here, I need to make some money, and I want to earn a little bit of money, and can I rake some leaves?" And I watched that kid go down the street, and he walked up to those houses, and I was watching him rake leaves, and y'all, so a world of terrible gloom and doom news. I mean, there's some good news, right? I mean, here's a young person out there hustling and not afraid to work, and the parents told him that's how it is. I mean,
Yep.
I love that.
Yeah.
Don't have any kids myself, and I was so proud to see that.
Yes.
That's awesome.
The good Lord sends me a message every now and then when you want to give up. Say, "Hey, here, I'll send you a little story to show you to keep on reading.
Yeah.
Don't quit reading." Anyway,
Randy, we have a couple of other questions.
Okay.
One of them is you had talked about how you can you went back on the roots that had the nodules on them and the healthy tomato, and the question was, how can you intervene? And then you mentioned plant marigolds nearby, don't plant your tomatoes in the same place every year. Did you have any other words of wisdom on that one?
Yeah, and let me just expound on those, just to amplify, why I even said those. Y'all, and I mentioned George Washington Carver. He was driving through the South. He was probably the father of modern agriculture, and noticed that over the years that the cotton planted in the same field was just doing poorer and poorer. And he theorized it was, they're pulling the same nutrients out. I mean, cotton feeds on what it feeds on. Like lettuce, for example, is a high nitrogen feeder. If you plant lettuce in the same spot every year, you better have supplemented with some nitrogen, or the subsequent crops will not be very good. So whatever the plant is, doesn't matter. If you plant that same plant on the same piece of ground year after year after year, it's going to keep pulling that nutrient out that it really pulls out, and it's going to eventually not do that well. So that's one reason for crop rotation. Another reason is that I described about the tomatoes specifically is tomatoes are prone, for whatever reason, well, root knot nematodes, there's something in that tomato root that they like. And so if they will go to that plant, if you've got root knot nematodes in your soil and you plant tomatoes in there, they will go there and find them. So now, typically, to create the kind of damage that you saw in that picture, it takes, well, I'm trying to go back, but it takes a long time to build up the numbers to create that extent of damage. So that was something that was a good example of, they had not rotated those crops for year after year. They kept putting tomatoes back in there. And just like anything, if you bring something that something keeps liking to eat, you're probably going to not get rid of that till you quit bringing what it likes to eat. So over the years, usually 3 or 4 seasons, you're going to build up a load enough root knot nematodes that there are going to be enough of them that they will start affecting the plant. So let me just say this, unless you pull the plants up by the roots and inspect them, you're going to know what you had and when it started. But I would hazard that if you're a tomato plant grower, and most people that grow food in North Texas, that's one of the main things they like to grow, you're going to have some root knot nematode evidence just about every year. But the first year you pull them out of there, you may have 1 or 2 knots on the roots because they're just not there in the numbers. But especially if you pull that up, that is one case. If you pull that up to inspect it and you see that they're there, you discard those roots. You can compost them because 140 degrees will kill pathogens and seeds, but you don't leave that in the ground. That's how those root knot nematodes can reproduce and increase their numbers. And so next year, if you go back and you go again, the next year you're going to have a few more, and then the next year there'll be a bunch more, and then by that time you're just planting right in a root knot nematode colony because they overwinter in the soil there in that root leaf litter, in that root litter that's left. So crop rotation is for the pathogen and for the nutrient component too. And again, the marigolds, get in, there's reams of books out there about companion planting, and it just so happens that they they secrete a substance through their roots that root knot nematodes do not like. And y'all, there is real validity to that stuff. I mean, these are observations people have made, and companion planting it's a real thing.
Yes, even among the native plants that we.
Oh yes, and lunar cycles too. I don't get too woo-woo and stuff, but I learned gardening from my grandma, and if she planted by the signs, and I mean, if the moon was wrong, and stuff but here's another thing too. Let me just say this too. When they were planting, it wasn't like us. Who here depends on what they're growing to eat? I mean, and I'm talking about y'all's grandparents and your parents too, probably. They couldn't afford to mess around. They weren't playing around or experimenting. They canned their food. Their gardens had to work. So when they put stuff together, it wasn't because it all looked pretty. There was no aesthetics involved. It was it was function over form, man. Form follows function. I forget how that goes, but let me tell you, that stuff, most of that stuff comes from anecdotal evidence, and you know, there's real power in anecdotal evidence. Because, like I say, they couldn't afford for their crop to fail. They had, if they wanted to eat that stuff, they had to have it, because there wasn't no going to the store and buying it. Because y'all back then, food didn't get trucked in here from California and Mexico. You know, they didn't. It was just talking about in the 40s and 50s, 30s, 40s and 50s. But what they taught us, what the things they did, and like what you talked about, Frankie, and what y'all, you saw it, you grew up with it. So this isn't anything new. What we're doing now is we're just going back to nature and forgetting all the middlemen and all the chemicals and stuff. And this is how it all evolved. And once you get this process started and going, it's easy. The plants respond because it's what they know.
Yeah. Yes. Well, thank you for that. Have one more question. Where can you get your soil tested? Is there a way to test your soil for
Man, that's a great
bacteria?
That's a great question. Let me say this too. Most soil tests, and I'm an Aggie, don't send your soil to A&M. Don't send it anywhere like that, because what they do is they take your soil sample and they dry it out, and they're going to test it for the available nitrogen, potassium, phosphorus, whatever. But what did we talk about earlier about what's in the soil? So what if they tell you that you've got 40% sulfur and that's what you're supposed to have in your soil? So what if they tell you that? Okay, that's good to know. You got it there, right? But y'all, and I'm going to get this wrong, but if you Google it, you'll come up with it. It's called the South Texas Soil and Food Lab. You don't want a soil test can be good to tell you what you've got there, what the potential is. Do you have potassium? Do you have phosphorus? Do you have nitrogen? And in what percentages, okay? But what you really want is a leaf petiole test. The leaf part, the big broad part, usually is connected to the plant by a little stem. That thing's called a petiole. What you do is you take that and you send it to them and they analyze that. And what they tell you is, what is your plant taking up? So one test, so what I would do is I get both tests, because one without the other really doesn't tell you anything. One, the petiole test, to say it tells you it's taking up phosphorus. Okay, well, if you didn't do the test that said you had phosphorus, you'd already know you had it because it's in the petiole, right? If it wasn't in the soil, it couldn't be in the leaf petiole. But if your soil test, for example, shows that you have sulfur compounds, but your leaf petiole did not have many sulfur compounds in it, and your plant was showing signs of sulfur deficiencies, then what would that tell you? It would tell you that your bacteria, the specialized bacteria that make sulfur compounds available to the plant, are not there. Because your soil test showed I call this a static soil test, because it just tells you statically what you got. The petiole test is it's a dynamic soil test. Does that make sense? Mm-hmm. So if I've got a static soil test, it tells me I've got a lot of available sulfur, but I've got a petiole test that's telling me I don't have any sulfur actually getting into the plant tissue, then I can, I'm a dummy. Listen to me and look at me. I ain't smart, but I can surmise that somehow or another, those sulfur compounds are not being liberated from that soil. We know what liberates sulfur compounds and makes them, well, not liberates them, makes them in a form available to plants. And if plant ain't getting it, then you probably don't have that bacteria. So how would you get the bacteria then? Make some compost. Or if you live close to an area, rangeland, not farmland, not cropland, a prairie, go out there and dig up some of that soil. There's going to be the best soil biology in the world out there, way better than you'll find anywhere else.
Yeah.
Old cemeteries, one of the best places in the world. Go find native plant seeds and soil. Old cemeteries, go find the oldest headstone in the world, and you got the best, oldest soil there.
So
Y'all,
the
I'll
name
tell
of
you,
that was South Texas
Yeah.
Soil and
Soil and Food Lab or something like that.
I get in a little
But
trouble.
it'll pop up. It'll pop up if you get that South Texas Soil and Food going or something. That'll come up. But you want that leaf petio test. And I hope that makes sense to y'all too, because like I said, the soil test by itself, it'll tell you what's available, and that's good to know. But it won't tell you what your plant's taking up.
how do you spell petio? Leaf petio.
Well,
Pedilo. Is that what you're saying?
Petiole. Petio.
L-E. Okay.
Just like it sounds, Carol. What's wrong with you?
I was trying to
Yeah.
put it in our chat.
No, listen, that's what I'm saying. If anybody if nobody wants to read my phonetic dictionary, Randy Johnson's phonetic dictionary, petio, P-E-D-I-O, but it's P-E-T-I-O-L-E. Believe it or not, I can do all the spelling of all the Latin names of the plants. I've just got a weird brain.
Okay,
But,
we'll go with that. Thank you, Randy.
well, y'all are sure welcome. Any more questions?
Not in our chat.
Well, y'all listen, again, the email's there. Y'all got my phone number, and I love to talk about this stuff. So, and I'd love to help. And if y'all got any questions, y'all please email me. And y'all, thank you for the questions. It's nice to see y'all and meet y'all. And, you know.
Well, we really appreciate your time tonight. You're a wealth of information, and you're so excited about the subject matter.
Well, you know what? I've seen the difference it makes. You know, I say I don't want to spend a lot of money. You don't have to. And, you know, the chemicals aren't good for us and not good for our kids, our grandkids, other people around us. And the earth will take care of itself if we just give her a little help, you know. And I mean, the native plants is how you start that. And again, no chemicals, native plants and no chemicals. And then throw in your edibles and your herbs and stuff, your medicinal plants. You can ride out any COVID. You can ride out any epidemic because you don't ever have to go nowhere to get nothing.
So what kind of consulting do you do? Would you solve people's yard problems? Do you do, people want organic flowers or yard, they want plants, organic plants? Do you do that kind of stuff? Typically what do you help people with when you do consulting?
You know what? Most commonly, people are wanting to put in native plants, put in pollinator gardens, and so in their yard they don't really know what native plants are. You know, like what is a native plant? What species are they? I've got a lot of shade. What can I grow here? Or it really runs the gamut. But most of the time, people are trying to start pollinator gardens. Some people want to get food going, and I tell them, look, you know. And a lot of them want to go with raised beds. I'm like, intersperse these in your flower gardens. That's where they're going to meet the most pollinators, and that's where they'll do the best. That's how they live in nature. Food plants did not evolve as a monoculture in nature, you know, and really the food, what is it for? It's for seed dispersal. So treat it just most of them like any annual. Most are annuals, and just throw them in there if it's enough sun to support a perennial. But Dick, like I said, we're doing large scale restorations on prairies, through my company, wetland mitigation. Guy wants to grow cows. We can talk about native plant restoration stuff, but typically it's urban stuff, urban homeowners with issues. But I've been blessed in my work to do a lot of different things, like I say, from composting to edibles to native plants, plant propagation, habitat management, habitat creation, tinctures. I'm into plant tinctures now because when this stuff started, I grow wild quinine, for example. I don't know what to do with it, but I've got quinine. I mean, I've got toothache tree. I've got stuff for psoriasis. I mean, for pain. I mean, I'm just 61-year-old kid just still doing it. But if you think of it, if I don't know about it, I'll read up on it and then come talk to you about it. I mean, one of the big things I'm doing now, I'm working with Dallas Independent School District, and this is fixing to get expanded to Fort Worth in conjunction with the National Wildlife Federation. I'm working with these ladies, and we train the teachers, and we go put in school gardens, and we help them with their curriculum and integrate that into the school garden, into the curriculum. And I mean, to be able to get with youth and all this and mentor them is really a blessing. And that's a big thing I'm doing. But, you know, I say there's a lot of common sense to this, and, you know, I just like helping people. I want them to be successful with what they try to do with their plants, and because I know it benefits everybody. This pollinator flowering plant relationship is, I mean, it's every terrestrial ecosystem on Earth. That's another PowerPoint presentation I do. It's called An Ancient Marriage, Pollinators and Natives. Talk about that co-evolutionary relationship. But, you know, we're blessed with certain things, and you're supposed to share your blessings. And that's, you know, I ain't bragging about it like I got something special, but whatever I do, God, I think it needs to be offered up. And like I said, I got a different way of offering it and different way of making I'm a teacher. My gift is to be able to turn something that's complicated and try to make it into something that's digestible and palatable and make it usable stuff. You know, the best information in the world out there, if it's not usable, is useless. It's got to be put in.
You know
It's
how
like
to
that.
get,
It's
you know
like
how
that.
to get rid of privet?
Just like Bermuda grass, you need about 10 lifetimes. Well, but no, there is actual. Now, y'all, let me say something else too. I'm organic, but I've done a lot of reading too, and I'm willing to learn from people. When you're trying to get rid of certain things, there have been, and when you're talking about a lot of time and money and energy getting put into something, you don't really want to do it over and over again, especially if it's not going to work anyway. It's been proven over many times that to really effectively get rid of things like Bermuda and privet, if you can do it in 3 or less applications, herbicides can actually be innocuous. And I've seen studies, okay? It's repeated applications for no apparent reason, just year after year, because farmers or ranchers, and they don't do it really as often as people think because these products are very expensive. But if they just like on July 1st, we do this every year or every month, we're spraying something, that's where you can get in problems. Because if you don't use them, what they found is they come back, the Bermuda or the KR blue stem, Johnson grass, privet, they come back and they ruin the restoration every time. And what they found without exception every time is if you use them in usually 3 or less applications, it's very effective at getting rid of the problem. They don't come back, and they see no long-term effects. So, matter of fact, they've done some studies with glyphosates, Roundup, just like oil slicks. There's certain things, bacteria that eats oil. They have now identified soil biology that will consume glyphosate in its raw form and break it down into inert compounds. I mean, that's a game changer. We can now remediate fields that have been ruined with Roundup and using just biology. And it's another thing too, it's not residual. In their system, it's not like DDT that comes out DDT. They can break it down into the primary elements. And that is total neutralization, which is so that they found that out by accident, but still. So just know that a limited use of herbicides to get rid of things. But what you want to do there though, Dick, is you want to wick those plants. You cut them off and create a surface area on the stump. And then you're using like a Q-tip applicator. You wick that stump. So you're not spraying where you can't get spray drift or it can't get on surrounding vegetation. So you can isolate the herbicide very nicely. The privet's tough.
Randy, we do that with the vine and stump killer when we have a shrub or tree that's unwanted, and we cut it down to ground level almost and paint the stump, you know, and it stays gone. It really does. It works well.
Well, and you know what they thought at first was that it would be residual in that stump after it killed it, and then it would pollute the surrounding soil as that broke down. But that's the study they did to find out that why it wasn't, you know, leaching out into the surrounding soil, because it was being decomposed.
It was absorbed, yes.
No, not absorbed. It was actually being decomposed and broken down.
Oh.
That was critical. And they were like, where's it going? It's not residual. It's not in this tissue, you know. And they were like, and they started looking around at the biology that was there and going, well, let's start breaking this biology down and looking at it. And they started, and then they said, could it be it? And then they introduced it, and sure enough, that was it. It was like, okay. But has anybody ever seen it advertised that go ahead and use it because it's still not safe? It's a carcinogen. So, but all I'm saying is that some of these herbicides, you know, they're not as bad if you use them on a very limited basis. Because again, if you don't, and it comes back and pollutes your restoration, what have you done? Wasted a bunch of time.
We
It
use
all
a
boils
little
down.
brush, you know, a little like a little paint, a nail brush, you know. That's what
Yes,
we.
ma'am. See, and like I say, that's a very ethical and very effective way to use it. And you can see, and if it killed all the stuff around it, you wouldn't do that. But you haven't noticed anything adjacent to it dying at all. Well, see. Then it sounds like I'm advocating the use of herbicides. I'm not, but I'm telling you, if you want to get rid of privet, I say, because privet's a habitat destroyer,
Yeah.
I say break it out. Let's go. Let's get rid of it and be done with it and get on down the road.
All right.
We agree with that.
We don't want to keep you any longer. You need to take off. I mean, we're just sort of chatting now after you talk. But
Well, if y'all want to chat some more, I will, but you have to let me go use the restroom. I'm an old man.
we probably need to let you go and probably need to eat something too.
Thank you.
Well, y'all
Randy.
listen,
That-
I've
this
really
is
enjoyed
great.
talking to y'all. And like I say, y'all please email me. I get my feelings hurt sometimes if I don't get an email after this. 'Cause I'm thinking, gosh, usually I've said something that generated a question or a thought. But anyway, but you know, one thing I will say about me is, again, not bragging, but most of the stuff, almost all the stuff I talk about, I've actually done. I mean, I've learned stuff from books, but also I usually apply what I learned. So I've tested so if I do a consultation with you, I'm telling you with practical knowledge and real world experience about what I'm seeing. That's why I even went into consulting, is because I saw somebody about to get ripped off on something. And I thought, wow, if she'd have just talked to somebody before she just $15,000 native landscape design, and it was all native plants, but put in the wrong place, too many of them, that kind of thing. And so, but I've done everything I've talked about. I've made the compost tea. I've applied it. I've seen how it works. So I guess that's kind of what makes me different than most people that you could talk to. Because, you know, a lot of people who talk to you say, well, how do you know, I've even been talking to people that, you know, it comes out in the conversation, well, I've never really done that, but I've, you know, seen it on YouTube. I'm like, well, you're not the guy I want. I don't want the surgeon who's only seen the surgery on YouTube. I want the guy that's done it 1,000 times, you know?
Yeah.
So.
Can we get everybody to turn their mute so that they can talk now? And let's give Randy a big hand.
Yeah.
I think he's done a terrific job.
Well,
Yeah,
thank
I
you.
do.
Thank you.
Right
so
click
much.
on your mute button, and that'll let you unmute it. That's the only way I was able to unmute, is just to right click on it rather than just click on it.
Well, again, I want to thank y'all for inviting me to share this, because like I say, I think it's important information. And again, you got to be given the platform to share. And y'all, thank you so much for your time. And again, the good questions. And again, I welcome any questions on the phone or email too. Text me, whatever y'all do. So y'all have a good evening. Everybody stay safe. Keep doing common sense, no matter what the politicians say. Wear the masks. I mean, it's just common sense. Take care of each other and be respectful.
Thanks
Thank
a lot.
you.
Bye, y'all.
Hey, Frank and Josephine, thank you very much for getting me on this tonight.
Thank you.
I really wanted to hear this, so thanks. Thank you all.
You're welcome. You're welcome, Phil.
All righty, I'm signing out.
All right.
Bye,
Bye-bye.
y'all.
guys.
Good night. Have a good Thanksgiving.
Thanks, you
Thanks,
too.
Randy.
Thank
Bye.
you.
Thank you.
Bye, John. Bye, Kay. Bye, John.
Bye, John Boy.
Take us out, Carol.
All right. See y'all later. Bye.
Okay.